Hello there. I wanted to do this recording before the next class so that I could have chapter 19 completed. So I'm just going to do my notes here on this whiteboard. And we're in the last section of chapter 19, section 10. Last time we had worked a little bit with, or talked a little bit at least, about the non-standard form of the free energy change. So let me start with that. Let me just write down that expression that we were working with last time. And of course, free energy change is delta G. If it doesn't have the superscript 0, then it's referring to the non-standard. So the expression for non-standard contains the standard delta G plus this RT times the natural log of Q. Can make that out, where, if you recall, the Q is a reaction quotient that's basically equal to the concentration of the products of the reaction, concentration of products over reactants concentrations. But the thing about Q is that both reactants and products are initial reactants and products. So it's not at equilibrium, and which makes sense because this is a non-equilibrium expression. So what we're going to do now is take this expression here that we had from last time, and I'm going to show you what happens if we assume that we're actually at equilibrium, okay, and with this non-standard expression. So let me see if I can get. If we take the general expression here for the non-standard delta G, and we say that let's just say that we're at equilibrium. So let's just take this expression and assume that we're at equilibrium. Okay. Well, if we're at equilibrium, then there's certain things we know that are true in this expression, and namely those would be that the Q value would be equal to the reaction, the equilibrium constant K. So that's one thing that's true at equilibrium. The other thing is that the free energy change itself, this delta G here, that's going to be actually equal to 0. Anytime you're at equilibrium, delta G is 0. So if we take those two things and we plug them back into this expression here, so we have a 0 on the left, and that's going to equal delta G, standard delta G, which remember, standard delta G is not at equilibrium. It's just at 1 molarity and 1 atmosphere pressures. So that's still there, plus RT ln, this time it's ln of K, equilibrium constant. And what that does is it gives us an expression that relates equilibrium constant to standard free energy change. And that's going to be a really little helpful thing to have. So let's rearrange this first, and then we'll look at it a little more closely. So if we bring the delta G to the other side, that's going to give us a minus delta G over there, delta G 0. And then the right-hand side will just stay as RT ln of K. And then we can switch the negative sign to the other side, multiply both sides by -1, and we end up with the expression that we usually will have that relates these two, which is delta G0 equals minus RT ln of k. And that's the relationship between equilibrium constant k and standard free energy change. There's also another relationship we can get from this one. So let me make some room here on the page to do that. Write that at the top. That's going to be delta G0 equals minus RT natural log of K, equilibrium constant. So what we can do with this is we can kind of rearrange this also to solve for K. I'm not going to show you the steps for that, but if we rearrange this whole thing, it's going to be in terms of delta G. So we're going to get K equals E to the minus delta G 0 over RT. That whole thing is in the exponential, this whole part here. And we get an exponential because we were taking the inverse of the natural log function, the antilog, which is the exponential. So we have this expression now, and next class period I'll talk a little bit more about that, but just point out again that in this expression, the R here is the gas law constant, but it's the one that's energy, so it's 8.314. And the T here, the temperature, has to be in Kelvin. Okay. So I'm going to stop that now, and I'll do another video either during class or beforehand, working out some problems, doing some calculations with that.